Okay, we continue. So now you know the product rule, right? So product rule, I'm just gonna repeat it. So product rule is like if y is a function of gx and hx, so dy by dx, like the derivation will be g as it is, the derivation of g with hx plus hx, the derivation, and g of x as it is. We can also call it u into v form. U as it is derivation of v, and v as it is derivation of u. Now let's see the division rule. Don't worry. After like at the end, last 10 minutes, I will answer your question. I know. I just saw the someone send the picture. That what is that? So I will tell you at last 5 minutes. Okay. Or you after the class you can ask me. So now let's say if y equal to function of y is a function of reciprocal, that is 1 upon g of x. This is reciprocal function. Then how to do that? How to get this function? That's the division rule, right? Remember, this is only possible if g of x is not equal to 0. So it's conditional, because if it's 0, then it doesn't mean anything, right? So dy, what will be the dy by dx? So let's see. If function is 1 upon dx, then what will be the error? Epsilon, x plus epsilon. So can I write like this in this way? Yes, I can. I think I can, right? So you can ask the rest of the students to join this session, because there are some students which are not here. So just tell them to join this group. Okay? If there's something happened because of that, we just lost the previous session. So I started the new session. Okay? Anyway. So what will be the dy by dx? Same formula, right? Same thing, same theorem. We just apply this in this. So can I write this in such a way? Minus upon epsilon. Yes, I can do. Then solve it. After solving it, I can, because if you know 1.2 upon 3, so this will go up, right? So this 3 will go up, and it will give us 2. So after solving that, you can take the LCM, least common multiplier, and just put it here and take it out. So what will you get? You can get g of x minus g of x plus epsilon, which is here, g of x minus g of x plus epsilon. And here you can have epsilon g of x plus epsilon into g of x, right? That's how we get it. Now we know that g of x plus epsilon is differentiable and continuous if epsilon tends to 0. So g of x plus epsilon tends to g of x. Can I write this? Yes, I can write this. So it's an NB number. So can I write this into this? So it will give me g of x plus epsilon minus, just take this minus common, and minus g of x upon error into 1 upon g of x plus epsilon g of x. Right? So what is this? This is the derivation of g of x with minus sign here, because that's how we did it. We just take minus common, and this term will be this times 1 upon g square. So it will be minus g of x upon g square. So it means this gonna be minus g prime of x upon g square. Do you understand? So this is the reciprocal function. We get it after deriving the theorem. Now, let's take, we have another function. That's the division function. If the two functions are being divided by each other, then h of x, or let's say we can write in this way. Why? So what will be here? So if y equal to h of x upon g of x, so what will be the dy by dx? Now we know this function, right? We know this thing. So we can just simply apply the same rule and find the ratio, derivation of a ratio function. So can we write, if y equal to, can I write in this way? What is dy by dx? Is h of x times 1 upon g of x. And I need to take a differential of this thing. Just apply product rule here. So what product rule tell us? That first derivation of first function, second as it is, right? Plus derivation of second function and first as it is. So we know so take we know this one, plus minus g prime x upon g square into h of x. Right, so here it's g, here is g square. So can I write like this? G square h of prime x into g of x minus this as it is. I can write this. So that's the derivation of a ratio function, right? So I can say h of x g of x minus g prime of x. That's how we get the derivation. So that's the division rule. Do you understand? Okay, have a look and then we can go next. Now you know how we derived all these rules of differentials, which next onward, you're not going to use the derivation, but you should know. So if you feel any problem, you can derive by yourself to verify it. Okay, now I'm going to erase this. So it's not difficult. It's really simple once you know this thing. What is higher order derivatives? Higher order derivative means derive again and again. For example, y equal to function of x. So what is dy by dx? First time derivative. This is first order derivative. Right? Then what is the second order derivative? Again, differentiate this with respect to a x. So dy by dx, which is f double prime of x. That's second order. Why do we need it? We will tell later. I will tell you later. Second order. But these two are really commonly used in economics and finance. There can be further orders like third order derivative, fourth order derivative, and even we can go higher and higher. But remember, in optimization, we have two conditions. One, first order condition. Second order condition. First order condition means first derivative is equal to 0. Let's say y equal to 3x square plus 2x. So dy by dx will be 6x plus 2. So we apply the first order, we apply the first order condition, and we get dy by dx equal to 0, which means 6x plus 2 equal to 0, which means x equal to minus 2 by 6 equal to minus 1 by 3. So this is the optimal value of x. So whenever we want to get the optimal values, we just do the first order condition and check at what value of x we can get the maximum. We can check it for the profitability, the returns, that what is the value of investment that we can have like maximum return. So you can also apply optimization in finding different portfolio. And second order condition means if you again derivate this function, it should be minimum. It should be less than 0. So let's say if you derive, if this is the function now, this is f prime x exists. Now again derivate this with respect to x, and this will give us 6. So it's not less than 0. So it means it doesn't fulfill the minimum, the second order condition, which is minimization, right? So this is giving us the maximization. Hence, this function is not the optimal function. So we can just skip. So that's why we need first order and second order condition to get x. First order to get x, second order to get the shape. Okay. Now, what we have, we can have like some other functions, which is like simple functions. That is log then we can have chain rule. Chain rule means every function is connected with another function. So if y equal to g of x, h of x, and f of x, so this is not multiplication, this is chain, right? So it means like if y, there are two functions, y equal to function of x, right? And x is a function of z. Then what will be the dy by dz? So what we can do, we can say, we can get dy by dx, and then we can get dx by dz, right? So here, can we write this dy by dx times dx by dz? So it gets cancelled. Oh, sorry, I'm mistaken a little bit. Z is another function of x. So what is the dy by dv? So it will be dy upon dx times dx upon dz. So it can give us dy upon dz. So first we get dy by dx from here, differentiating this. Then we can get dz by dx here, and then we can put it in a reciprocal way here, and we can get this. So that's the chain rule. And you can, if you can have more than one function, you can keep continuing. So it's really simple. So whenever there is a chain rule, y equal to h with chained with f, right? Let's say. So the differential will be h differential times g differential times f differential. Just as I told you, different function, right? dy by dx times dx by dz times dz by db, just to get dy by db. Example. So this is the chain rule, very simple. So we already know the higher derivative. So next, let's see partial differential. Partial differential. As from the name, it means part. It means not the complete differential. So this is the case when y is a function of different variables like x1, x2, x3, x4, so on, right? So in this case, let's say y is a function of 3x1 plus 9x2, 3 plus 4x3 square. So I just want to differentiate y with only respect to one variable, that's x1. So if I want to know partial y by partial x1, that what is the rate of change in y with only the rate of change with x1, not them. So I consider all the remaining as constant. So, and we know the derivation of a constant is 0. So we will only derive this one, and this will be the 3. So that will be the answer of partial y upon partial x1. We can also use it in a chain rule. Partial y upon partial x2 will be 3, 9, 27, I think. 27 x2 square. So I can also get a partial x1 upon partial x2. Right? So what is the rate of change in x1 with the rate of change in x2, which I can just do like this. Partial y upon partial x2 times partial x1 upon partial y. So we have partial y upon partial x1, which is the opposite will be 1 by 3. So, and this we will get 27. So I can write it x2 square times 1 by 3. So it's 9. So it gives me 9x2 square. That's partial x1 upon partial x2. So there are different manipulation you can do it with these kind of things. And similarly, if you want to take with partial x2, so we only differentiate this. This is constant, this is constant. Do you understand? We can also say, instead of x1, we can say x, z, l, 3 variable. So then partial y upon partial x, partial y upon partial z, partial y upon partial l. So when you are differentiating with one variable, the other is going to be constant, and the derivation of constant is 0. There are some few students, means 18 students who didn't join today. I hope that you are also getting the attendance, right? Because at the end of the semester, it is really important to understand. So that's the partial differentiation or partial function. Now, last but not least, I just want to tell you a little. So this is all about differential. So these are all the things you're gonna play with again and again. So at home, before the next class, just have an overview of this. And on Wednesday from 7 p.m. to 9 p.m. is my office time. So I will be available on Ding. So you can contact me here. And if you have some questions, you can ask me here. Okay? So this is the office time from now onwards, other than the class. Okay? But first, email me or write me a message that you want to join or you want to join the discussion. So it will be an open discussion together with the other students as well. So you can come up and you can just ask your questions, okay? Now, what is integration? Maybe you have heard with this. Integration means to integrate. Differential means to differentiate, to take away the things. Integrate means integrated together, right? So it means it's opposite to differentiation. Just remember, it's shown with the sign this at some S point. So in differentiation, we have this thing, but in integration, we have f of x d of x equal f of s. How? Let's see. There are different ways to show it, to nominate it, to give a notation. So some people, they write f of t dt, some equal f of s. Some people even write just simple f equal f of s, right? So this is there. I have like a differentiator here. This is a machine with the integrator. You put the machine here, it integrates into one. So most of the rules, they are opposite of the differentiation. Let's just take simple example. How to integrate this? Simple. We just do like this. This is because this is s, so it will be s3 upon 3. It is opposite, right? So how do I know? Because if I differentiate this, I will get this. It's also known as antiderivative. So if I do like this, d by ds of s3 upon 3. So what will I get? 3s square upon 3, which is cancel, and it will give me s square, same as it is. So that's why it is known as integration. We're not gonna go further because they also have some rules of integration which you're not gonna use in this lesson, in this course. So we're just gonna ignore it. Next portion is about matrices or matrix. What is it? Let's talk day after tomorrow on Wednesday. Okay, Wednesday morning or next class, whenever we will have the class. So let me go to the eViews. So I'm gonna just turn it back, the system. Oops. So now I'm gonna share the screen so that you know how to install the eViews in your lesson. So first, if I share the screen, which I already did, and I think I have to cancel the camera, something like that. So this we will talk about next lesson. So now let's have a quick look about different differential things. So we already know these. We already know these. You know how to calculate this. I think I didn't miss anything. This is division, this is product rule, this is subtraction, this is oh yeah, this is another rule, right? So you can have a look here. So I will also share this. So it's simple. You can apply the same formula there. Then you know higher order, first order condition, second order condition, partial differentiation, right? So these are different chain rule, optimization, and so on. Matrices we're going to talk about in next class, that what are different rules and how it functions. Now, how to download eViews. So let's see. First of all, eViews is a software. It's a really friendly software. Where you go on Bing or Baidu. You go to Bing or Baidu. Listen carefully. You just write down, or you can also go to Google, because in China, Google may not work. So just use eViews 11 official. So it will take you to the official website of eViews, this one. Just click on eviews.com. It will open another window, which is this one. So which one do you need? Student. All right, so this one you click. No. We have to go further back, because this is not the same thing. eViews student version 11. Oh yeah, so then you can do this. So that's a request. So what you did, you just simply search for eViews student version official, then you will have request eViews 11 student version light serial number. Okay, you click on this, you fill your field, right? So you can fill your name, your last name, your email, not necessarily your phone number, but you should put your school, university, and then you can select your country, and then you can go for graduate student or undergrad student or for others. Then just to fill this, and by clicking submit and request the serial number. So it will send, the serial number will be sent on your email. How? Let me show you. So then after that, after like a couple of minutes, you will download, you will see your email, and you will find yes, I don't know why it's so slow. So once it's open, I will show you. Yeah, so see, this is the eViews. Yeah, so when you will do eViews student version, you will get this one, and here, this request page. So you need to click this request page, and this will take you to that folder, to that file, and where you can input your details, and something is not right. Internet is working. Just simply, it will send you the link, and then you will have, let me see, where is the download? Yeah. Then you will have this much eViews installation, because I already have installed it. So I don't need to install it again. but you need to install it, unzip it, and then install it. Okay, and then you will have this sign here, EViews 11. Okay, and then later on we will see that how it works. All right. So next time we will start learning something on the EViews. Okay, so it's good if you can bring your laptops with you in the class, or even if you don't, just try to learn that how it works, because we're gonna do some exercises on EViews. If you remember, we're gonna talk about the different types of data, like cross-sectional data, how we put the data in the within the EViews files, panel data, and how do we do some graphical and tabular form representation, and some basic regression, some plotting, the lines like U-shape and linear function, quadratic function. How can we describe the data through EViews? The basic we're gonna learn tomorrow, and after like every second week we will do some EViews exercises so that you know how to do the software estimations. If we will have time, I'm not promising you, but if we will have time and we can have some extra week somehow, or if you want, we can arrange some weekend to learn about another software, but not now, which is R. Yeah, so we can learn a little bit about R, about Stata, right? So because these two softwares are also being used to conduct different analysis, estimation analysis. So if we will have time, to last 4 weekends, we will try to get like 2-hour class sessions on R, two weekends for R and 2 weekends for Stata. And this will be together for everyone, means for like statistics students, and for econometric students, and for international business students, right? So hope that you have learned from this lesson that how we derivate and how we do the derivation. So don't forget to